In 1928, Sir Alexander Fleming observed that colonies of the bacterium Staphylococcus aureus could be destroyed by the mold Penicillium notatum, proving that there was an antibacterial agent there in principle. This principle later led to medicines that could kill certain types of disease-causing bacteria inside the body. Originally noticed by a French medical student, Ernest Duchenne, in 1896. Penicillin was rediscovered by bacteriologist Alexander Fleming working at St. Mary's Hospital in London in 1928. He observed that a plate culture of Staphylococcus had been contaminated by a blue-green mold and that colonies of bacteria adjacent to the mold were being dissolved. Curious, Alexander Fleming grew the mold in a pure culture and found that it produced a substance that killed a number of disease-causing bacteria. Naming the substance penicillin, Dr. Fleming in 1929 published the results of his investigations, noting that his discovery might have therapeutic value if it could be produced in quantity.
Hello everyone, I'm Devin here. Welcome to our channel. Today we will explore about pharmaceutical industries. We'll talk about penicillin. Do you guys know what is penicillin? Penicillin is a natural product and a part of ancient traditional remedy thousands of years old. Penicillium mold naturally produces the antibiotic penicillin. Fermentation is the technique used for production of penicillin. It is a fed batch process that is carried out aseptically in stainless steel tank reactors with a capacity of 30 to 100,000 gallons. The fermentation involves 2 to 3 initial seed growth phases, followed by a fermentation production phase with a time cycle ranging from 120 to 200 hours. The overview of the process can be summarized into 4 steps. First, penicillium mold naturally produces the antibiotic penicillin. Second, scientists learn to grow penicillium mold in deep fermentation tanks by adding a kind of sugar and other ingredients. This process increased the growth of penicillium. Third, scientists separated the penicillin product from the mold. Finally, penicillin is purified for the use of antibiotic medicine.
Hi, I'm Anissa. Let's look at the background of our penicillin. For this part, we will be focusing on scenario involving the separation processes. Penicillin is an important antibiotic produced from fermentation. Therefore, it requires separation from the fermentation broth. Another part to be looked into is treatment of the aqueous layer after the extraction before discharge. Penicillin digestion by humans and animals is not perfect. Thus, concerns arise regarding its effect if it somehow accumulates in water sources due to human or animal excretion. This may affect balance of ecosystem due to its antibacterial effect.
Hello, I'm Chit Seng. I will explain the separation process. The first process is extraction. Centrifugal extraction found extensive usage for obtaining penicillin from the fermentation broth. Centrifugal extraction had a rotating centrifuge to mix as well as separate the liquid layer very thoroughly for greater contact for enhanced mass transfer across solvents. Meanwhile, the extraction refers to liquid-liquid extraction, which involves components distribution between two immiscible liquid, one usually organic and the other aqueous. The solvent choice is very crucial in this process as liquid-liquid extraction is an equilibrium-governed process. Reactive extraction may be utilized in addition to centrifugal extraction, and it occurs if extractant or the extracting solvent undergoes reversible chemical reaction with the substance to be extracted. Example of solvent includes ambolite La2 in N-butyl acetate, phosphate, borate or carbonate buffer at pH 7.5 till 8.5. Usually a re-extraction process will follow as very high purity is needed for pharmaceutical application. Let's move on to the second process, which is adsorption. In the separation process, present is adsorption, which can deal with the aqueous layer purification as well as green method to maintain water quality. Adsorption is a process exclusively occurring at the surface and frequently used in water remediation, thus is highly recommendable for the purification. Adsorption has 3 mechanisms: physisorption, chemisorption, and reactive adsorption. Physisorption occurs through the intake of adsorbate in the pores of adsorbent held together by dispersive interaction, also known as London dispersion force. Chemisorption occurs through the reaction of adsorbent and adsorbate to form new chemical bond. Reactive adsorption refers to breakdown of adsorbate into its constituent by the adsorbent. Among adsorbent, activated carbon can be a nice choice.
Now, let's look at the advanced separation technology in penicillin production. Looking into current advances in technology, hollow fiber renewal liquid membrane, or known as HFRLM, is an advanced method that utilizes porous and hydrophobic hollow tubes. These tubes are surrounded with aqueous phase, while organic layer covering the pores of the tubes. At the same time, aqueous phase with suspended organic droplets flows in the tubes. The hydrophobic tubes attract the organic layer to form liquid membrane. However, the liquid membrane can be peeled off by shear force. There are a few advantages of this method. This renewal of membrane reduces extracting solvent consumption, enhances mass transfer, and increases stability.
Yes, my name is Ahmed Al-Qawi. I will explain the stability part for the production of penicillin. After using the active carbon, the absorbent in the absorption process, it will be sent to treatment, so it can be reused. The active carbon activity depends on its temperature. So, by using the heat treatment, we can remove absorbent as the first step to reuse the active carbon. After that, it will be undergo filtration using the water. The water absorbs molecules and organic material from it. However, there is a drawback for this treatment. The active carbon loses about 5 to 10% from its efficiency. On the other hand, for the expand, the distillation is commonly used as for certain metals. The water that we use as a filter to active carbon should be replaced periodically. For that, the replaced water should be undergo treatment to remove the hazardous chemical material within. And the most common method to do that is